So instead of using the definition of Taylor and Maclaurin series, which says take the derivative, the second derivative, the third derivative, the fourth derivative, and then substitute 0 in Maclaurin's case, other numbers in Taylor's case, instead of doing that, start with the series that you already know. So for example, you might look at the natural log has a series that looks like x minus 1/2 x squared plus 1/3 x to the 3 minus 1/4 x to the 4, etc. Or in other words, that's x to a number divided by that number, and it needs to alternate. And it starts with 1, x to the 1 over 1, and it does not start with a negative, so don't put this as n, have this as n plus 1. So in other words, there's a known series for natural log of 1 plus x. Well, how can we manipulate this using algebra to turn it into that? Well, obviously we could put a 2x in place of all of these x's, just put a 2x, but then that would be a series for 1 plus 2x, not minus. So how could we get a minus 1 in there? Well, there are no formulas for the natural log of one thing minus another thing, so we can't use the laws of logarithms. What other algebra could we do? Well, if we substituted a negative 2x in here, we would have the natural log of 1 plus a negative 2x, and then that's close, but it's supposed to be a positive 2x and it's supposed to be a negative 1. Can you just multiply both sides by a negative 1? Well, sure you can, but does that solve the problem? Many times in algebra that would, because if you distribute this negative, it would become a positive 2x and a negative 1. The problem, though, is if you multiply by a negative 1, that means you've got negative 1 as an exponent, which then says invert this, and you've got 1 over this instead of what we wanted. So that doesn't seem to be working. So we could go back to the drawing board. There's another series that looks like this. So this one is just x squared, x cubed, etc., etc. So this series actually starts at 0 to infinity, and then it's x to the n. So can we manipulate this? Because now that idea of multiplying by negative 1, now that we just have algebra on both sides, we don't have logarithms, now that idea of multiplying by negative 1 will help. So multiply this side by negative 1, and multiply this side by negative 1. That's going to switch and make this x minus 1 if you distribute the negative along the bottom. And then this will be, you really can just leave it as negative 1 in front, or you could say it's negative x to the n. I would prefer that you leave it like this in this particular case, because this means all terms are negative. This also means all terms are negative. But some people might think that means, oh, take a negative and raise it to different powers, that means it's going to alternate. No, that would be if there was parentheses in here, but this is not saying that. This is saying take a negative 1, multiply everything by it. So maybe I could emphasize that by saying a negative 1 multiplied by all of those. Okay, also, instead of an x, we need a 2x. So just make this into a 2x, as long as you make that into a 2x. So this now needs to be in parentheses and say 2x is being raised to different powers of n. Now if we just integrate this, that's pretty much what that's going to be. So now integrate both sides. So on this one, it's going to be, that's the natural log of 2x minus 1. But there's also the chain rule, so you're going to have to divide by 2. And then for this one, we still have that it's an infinite series. Integrate these terms means you have to add 1 to the exponent. And then divide by that number. And the last thing to do is multiply both sides by 2. So the natural log of 2x minus 1. So I'm going to multiply this 2 over to here. So negative 2 times, and then it's 2x to the n plus 1 over n plus 1.